asking me a question here. Very powerful capabilities with energy and anti-gravity and all that. So we have to actually be ready for it before we can.
Yeah, and so this idea about perfect embedding being what holds the proton and the electron also implies certain technologies. For example, if the geometry of the coil pairs in the Keshe device are electrical examples of perfect embedding, which makes them conjugate and therefore cohere the vacuum, you know. So the point would be that the civilization will really take notice when we build a gadget based on the physics.
Yeah, that's when they'll take notice. But then, like you mentioned the other day, the energy devices, it's not free. You have to use it properly, otherwise you can cause a lot of damage. And that's why we have to raise our consciousness first, and then prove it with devices, and then it should take off from there, you know.
Yeah, and what we said about that was basically that when you cohere the vacuum with a vacuum coherence device, a zero-point energy device, you're basically withdrawing charge from the gravity field. And that's okay if it re-enters the circulation, but there's a sort of Atlantis mistake implication there. That's why we do suggest not calling it free energy. But yet, pine cones do it fine, and they don't cause their continents to tip over like Atlantis. So,
Yeah.
but it's basically energy that's entered perfected distribution. So if you create perfected distribution, in effect, you create gravity in the same way that grounding is perfect fractal charge distribution.
Yeah. Hi, Eden's asking what happens to the percentage of the charge that's not in phase conjugation and embedding. Now, I'm thinking, like, if we're talking about gravity and things like that, the percent that's involved in it is what's going to be part of how you relate electromagnetism to gravity. The rest of it would just be the ambient electromagnetic radiation that just bounces around until it's just dissipate or not absorbed in the environment. Something like that.
I think if you took the Earth grid as an example, famously dodecaecosa, and we know the dodecaecosa Earth grid was originally documented based on its effect on microgravity. So basically, being on the dodecaecosa Earth grid is part of entering perfected charge distribution. So if you're not on the dodecaecosa of the Earth grid, then your information is not as well distributed. For example, the Kozyrev mirrors produced telepathy only when placed on the Earth grid. So basically, not part of dodecaecosa in perfect embedding means less charge distribution, less networking.
Yeah.
And basically charge isolation versus charge distribution.
Yeah. Dan, it'd be nice if I could upload my document here.
Well, I'm going to make you presenter right now.
Okay, yeah. I know you have it up there, but I'm going to put up, yeah. So I think there. So now I can upload my copy so I can, or actually, I can navigate around. You have the latest document there, right?
Yeah, and in fact, if you click on
the
bottom, and if you click on the bottom, it gives you access to all the pages at once. You can scroll.
Click on the bottom. Yeah, select a slide. I see what you're saying. Yeah, there you go.
You take your time. You scroll back and forth slowly, and then you can pick a slide too.
Okay, there we go. That's nice.
Yeah, see now, and now when you see, we can't see those slides now, but when you click on one, then it will take us there. Now, see, now it's up.
Yeah, and that's what I was going to mention. The forms of the equations are real similar for gravity and the electromagnetic force. These are simplified, but so what I'm saying is we'll come up with some way to say what percentage of the electromagnetism results in exactly this gravitational force. If we can do that, or someone in the class, they're going to get some major recognition.
Yeah, well, I mean, the idea is that only by entering into conjugate geometry, like in the electron shells of hydrogen, is the coupling perfected between the rotational inertia and the accelerating inertia towards center. Yeah. And so the amount of charge coupling there would probably relate to some of the fundamental constants, like line structure or something, probably.
Yeah. I'm surprised no one's worked it out yet, but it's getting there. And here, one of my slides points towards the electric universe, and that's a complementary theory to Nassim's. Actually, I'll talk a little bit more about that during the class, how scientists separate the mass and the matter and the electricity into two separate problems, and handle it separately, even though Nassim is saying, hey, we really should be considering this stuff wholly. So
exactly.
We'll
That's the essential schizophrenic problem. People think that charge is separate from gravity, or that the fundamental forces are not fundamentally the same force. That's the problem. And the fact that you see it all resolved the electromagnetic is gorgeous. So if we just show how electromagnetic charge experiences acceleration, so what generates acceleration towards center? That's the simple question, which is what causes gravity.
Yeah.
And clearly it's phase conjugation.
Yeah, maybe you should put that equation on the cover of your book.
Well, the other thing I was just going to mention is that discussion we did where we derived, I believe it's the gravitational relations from the fine structure constant, just later. But the web link is goldenmean.info/predictions, and there's a geometric, in fact, the geometric analysis of the fine structure constant at goldenmean.info/predictions is specifically deriving the equation for the fine structure constant from the ratio of the translation of the vorticity on the surface of a torus.
Okay. Well, that's really interesting, is that fine structure constant is key in this proton-electron mass ratio.
Right. So specifically, if you go to goldenmean.info/predictions, about halfway down the page, there's a graphic that says Chapter 8, 2 equations. And one is the self-inductance of a circular loop of wire, radius r, cross-section r. And the other is a new equation for the fine structure constant. And they sets them one equal to the other. And it says the formula for the translation of vorticity on the surface of a torus produces the formula for the fine structure constant. And the ratio of the translation of vorticity on the surface of a torus is exactly what we're discussing about the ratio of rotating charge versus charge that accelerates to center of gravity. So later, we're getting carried away here.
Yeah, right.
But later, if you would look at that about how he derived the fine structure constant from the translation of vorticity on the surface of a torus, and we might be able to produce that ratio, that is the ratio of the amount of gravity produced by charge in mass.
Yeah, let's do that. We'll look at that later, because that would be a nice new equation to add to everything. Yeah, fun. Good stuff.
Actually, Eden, I did start the recording. Thank you. I thought we'd record the chat just for fun.
Good. That's good.
So yeah, but again, probably for people to take this seriously, again, in my experience, you build a gadget that uses the new information, and then they take you seriously. Which is why I think we apply this to implosion amp in the conversation with Evans.
Yeah, and then they do take you serious when you have the device, but even when the equations are so clear that it uses all of the mainstream parameters and derives some new stuff, even then it's hard to get people to listen until you have a device or something.
Right.
Yeah.
Exactly. But as you say, your equation should be compelling. Let's see. Devin Klender is asking for help with the registration code. That registration code worked for Liz. It should work for your friend Devin.
Yeah, it should. I used it too.
Have Liz remind Devin there.
Yeah. Okay.
So it's a bit after 8 here, which is after 2 there.
Yeah. Hold on a second.
Yeah, we have a few more. Let's give him about 2 more minutes, and then we'll do the little intro here. So Mark and I just decided that we're going to take this conversation into a new equation for the ratio of charge in rotation called mass that's converted to gravity, charge acceleration towards center, based on the fine structure constant and the translation of vorticity on the surface of torus from that article, goldenmean.info/predictions. Because when we say what is the cause of gravity's phase conjugation, we should be able to say then what is the amount of gravity created by a certain amount of mass. For example, if I'm saying the additional gravity in the universe that they account for by hypothesizing dark matter is in fact caused by the major masses of the universe arranged in a dodeca, which is known, which makes the phase conjugate. So we don't need the idea of dark matter at all. So that means that the amount of gravity we're making increases when the masses are at phase conjugate symmetries. So that's part of our equation to predict how much gravity you make. So when we measure the change in microgravity by moving masses out of conjugate symmetry, in effect, we could get information about that equation for how much mass it takes to make gravity depends on where the mass is placed.
Yeah. We got some work to do there.
Yeah.
Yeah.
Okay, so it's about 8:03 here, so it's 3 minutes after. Maybe we should begin, huh? Should we?
Yeah, let's go ahead and do that.
Okay, so then we said that I was going to do just a couple minutes intro for Mark here, and then it's all his.
Yeah.
So our honored guest this evening is Mark Rohrbaugh, who is Rohrbaugh, right? Rohrbaugh.
Rohrbaugh. Rohrbaugh. Roar like a lion, baw like a sheep.
Which is a good German name, is it?
Yeah, German Irish, I believe.
That's good.
Yeah.
So Mark has been a real hero for us with the Implosion Group and the Fractal U project. I met Mark because Mark had developed this equation for the proton to electron mass ratio, which started with Nassim's Schwarzschild proton, and in the process showed that since Nassim's Schwarzschild proton produced such a new accurate equation, radically, excitingly, for proton to electron mass ratio, that at the same time proves also Nassim's work on golden ratio and universal scaling and the idea of perfected embedding. In fact, the concept that the perfected embedding is what holds the proton quite literally in a pure geometric relationship to the electron. So it demonstrates the idea of perfect embedding and therefore supports the idea of phase conjugation as the mechanism of the connection, what holds the electron to the proton together. And if you start with that idea of perfect embedding and phase conjugation being what holds the proton to the electron together, it leads you directly to the ideas of gravity, which is where we're going next, and what we've been talking about in phase conjugate gravity. Yeah. Also, I'd like to mention by introducing Mark here that Mark has very helpfully been involved in our work with Armin and the Keshe project, and went to Los Angeles to evaluate the Keshe device, and that project is still underway with implosionamp.com. Our other engineer there, Evans Abelard, outside of Montreal, who is now actively making measurements with the new accurate phase angle power factor analysis of the Keshe device, and Mark is a consultant on that project, which has been supported and led in part by Chris in Belgium and the whole group there that's part of our other projects, implosionamp.com. So Mark's skills here are coming in on wonderful on many facets of the diamond here. Mark's background includes he does high-level solid-state electrical engineering work with, and maybe at that point I turn it over to you, Mark.
Yeah, my interest in this is, I'm a mainstream engineer. I design analog integrated circuits, the insides of the chips. I do digital as well, mixed signal. And I'm an independent physics researcher. I've been interested in physics all my life and make a living designing circuits. And to be a good circuit designer, I studied the solid state physics at the University of Cincinnati back in 1983, 84. It's been a while. And it turns out that some of that's the basics of quantum mechanics, a real limited form of quantum mechanics. They actually, some of the scientists sometimes call it squalid state instead of solid state, because the science of physicists battle with each other on who's got the best theories. But solid state, if you look into the history of the Higgs boson and that research, they say a lot of that comes out of the solid state physics. And to really get a good understanding of that argument, it's really good to know that. So I've been interested all my life, and however, stayed in the mainstream, just looking inside the box. And when I ran across and met Liz, she's the one who pointed out, I said, well, show me one woo-woo guy who's ever done anything. And that's when she showed me Haramain's work and I'm like, wait a minute, this guy's talking about problems I've been working on, in the background for years, trying the unsolved physics problems. That's where Richard Feynman says to focus. He's a Nobel Prize winning physicist. He says focus on the unsolved problems. Well, here Liz points me to Harriman, which then soon afterwards I found Dan Winter's work, and then Elizabeth Rauscher, and finding out there's a huge amount of people working on this stuff besides the mainstream, and we're getting answers. And that's the purpose of this course, is to show a handful of the answers that comes out of this work, and maybe it'll extend the mainstream or start a new theory. Well, the main thing is just revisiting the foundations of the mainstream science, and then they'll discover some of these relationships too, because we're not trying to minimize the value of the mainstream. It's really good stuff. But
I like it that Mark is in solid state. It has with FET, field effect transformers, and field effects ultimately get super complex one within each other, and eventually it leads you to this idea of nesting and embedding and perfecting compression, and that's where we come back to the seams in my work. Go ahead, compression. Yes.
Yeah, and the field effect transistors, the bipolar junction transistors, the solid state physics allows you to derive the device parameter or device characteristics, and even theorize about new devices too. So.
And originally it was about compressing the devices, as in a mass integrated circuit. But eventually it's simply the question of compressing charge, not destructively, the devices. And that's where we arrive at these equations.
Right. Yeah. So in this course, we're just going to review some of Nassim Harameyn's work, some Dan Winter's equations, and we're going to discuss the simplicity of the approach. We're using a real basic geometric and information theory approach, and the key thing is here we're bringing the ether back into science like it was over 100 years ago. So we're going to assume a constant density of the vacuum. And this is some real simple analysis just to show that we can get some answers and maybe start looking in other directions. We're able to, with these ideas, solve for the black hole mass radius relationship fairly simply, considering how tough it is with Einstein's field equations. Get the same answer too. We're going to talk about the proton mass, the proton radius puzzle, and then a few new precise equations for the proton electron mass ratio. And once you have that, you can throw that in the Avogadro's constant, the equation for that, and we'll look at a few of the phi ratio and Planck unit discoveries. And then I'll discuss how it's related to the sacred geometry. So let's see where we're.
Mark, would you say that when you said bringing back the ether, that the way I've been thinking about it in terms of a plenum of compressible charge, is that useful?
Yeah, it's hard to describe exactly what it is because I think that's useful. It's a big vast sea of energy, dynamic, fluctuating things. So there's a lot of ideas, a lot of things to call it. It is a super fluid, a conservative ether. So if you have any energy in it, the energy is always there. It's never going to dissipate, So.
And you could say the ether and charge both behave like a fluid, as Nassim agrees. So you're talking about the Well, anyway, go ahead. Yeah. You can zoom in a little if you like there.
Yeah, this is just the outline. So we're going to start off talking about the vacuum energy and Harameyn's Planck spherical unit. And this is some of the basic structure of the vacuum we want to talk about. And there's where we'll make the relationship to sacred geometry and the phi ratio. We'll be able to talk about the density of the vacuum and then treat the ether as a superfluid. And then some of the implications. And when I started writing my blog, I started out with the implications, and I wanted to mention that here is once you look at this and see how high that vacuum density energy is, and then you study, say, the mainstream view of black holes, it already implies we're already inside a black hole. We're just like we're vibrating in this ether, because we don't really have mass. It's just a vibration, an energetic informational vibration. Well, considering that really means anything is possible. And I like to start off that way, say anything's possible, but then we're going to show some specific relationships that come out of this.
Yes,
And
and all the speakers start with by saying the amount of energy in the vacuum is huge, and that's the point, and that leads to
yeah,
what we can. Yes.
yeah, and that's just incredible. And when you make that assumption and go through some simple geometric equations, start getting answers, and that's really fascinating. It's related to the resolution of the vacuum catastrophe. That's a big disagreement between quantum mechanics and cosmology, or general relativity, or whatever
And
large.
Planck could be that connection in a way, the Planck dimension.
Yeah,
That's
that's what.
the
Yeah, that's
resolution.
right. That's what we're thinking it is.
Mhm.
So then we'll talk about what is mass. I mean, everybody has their idea. We'll give our uh, answer to it, or way of thinking about it. And the importance is, this is what CERN with the Large Hadron Collider. That's what they're attempting to answer with the Higgs boson, is what is the cause of mass. And it turns out the Higgs only explains a percentage of the mass. It's still, in their theory, they need dark energy and dark matter.
Mhm.
And and
I
Harriman
mean,
does.
if you define mass as inertia, then the charge in rotation creates inertia. Is that a start?
Yeah, yeah, that is. We'll have to put it to some equations and check it out.
Gyroscope can.
Yeah. So then, like I said, we can solve some the black hole mass radius relationship, proton mass radius. We'll talk about the proton radius puzzle, and these other equations, the proton to mass ratio. I didn't add in this the I'm also going to talk about the four fundamental forces of nature. I should have added that to the summary here. That's
Outline.
a few new slides. Okay, so let's go to, this is the vacuum energy discussion. And I want to keep it simple, even though it's got a lot of slides here. But what we're trying to do here is first talk about density and define a few things. So using Harriman's Planck spherical unit, basically we take a sphere of diameter L. L is the Planck length, which I put the equation down here. This is one of the fundamental units that Planck defined by playing around with other physics constants and ratioing them and trying to get the correct dimensional unit. So whenever you put in the Planck constant, the speed of light, and the universal gravitational constant, take the square root of that, you can get that's what defines the Planck mass. Planck length is a similar type equation. When you put these constants in, do this equation, the units come out length. So
It's called dimensional analysis.
yeah,
Yes.
dimensional analysis, right. So what this is the amazing thing is you take these fundamental units, which Feynman hoped someday we'd be able to specify physics in these fundamental units, and I think that's what we're doing now. We are doing that now. Harriman proposed this, and you can derive this too, and I need to work on that. There's a way to derive some of these ideas, but he proposed looking at the density of the vacuum this way, and these spheres. So if you take that Planck mass and divide it by this Planck volume, which is 4/3 pi times the radius cubed, that gives you the density of the vacuum. And so I'm writing down the equations here, and it's a really large number. And let's say we're going to assume this is the density of the vacuum, and then we'll proceed from there. And I'll go to that in a second. But I wanted to mention this symbol here, the flower of life, or there's different things this is called, but this is a 2D representation of a 3D packing of these spheres, and they overlap. And they're not solid spheres. These are vibrations in the vacuum, and they overlap to where there's no void between them. And when you consider it that way, and this structure builds up the whole vacuum, I mean, and it goes on, as Hermes says, it always has been, always will be, and it goes on infinitely, even out of our, what things would, so far out that it wouldn't necessarily be, I was going to say be connected because of light speed, but anyways, that's theoretical speculation. But the key thing is that this symbol is, I mean, if you treat the vacuum this way and assume a structure of the vacuum, something like this, then let me see if I got on the, yeah,
I think even going
yeah,
back to that picture, Mark, that the way Nassim talks about it is that if you originally close pack spheres, that you get cube octasymmetry, which is stellated tetra,
yeah,
which is basically 12 plus 1. But if you take the center sphere out, the 13th one, then suddenly they compress and they jitterbug, and it goes to dodecaecosa or ecosa, which is the jitterbug, which is the superconductive moment, which is the charge collapse. So when those close packed spheres go from cube octa to ecosa, that jitterbug is actually the superconductive implosive. So there's something about that symmetry in the close packing the Planck spheres as well.
yeah, and that this is the key point, is when you talk about the very fundamental structure of the fabric of space-time. Well, there's spheres here, but then you find out that it's related to platonic solids, as you're saying, the tetrahedron, octahedron, the cube octahedron, icosahedron, and dodecahedron. These, like for example, down here in the lower right is this is meant to represent a dual star tetrahedron, as Nassim talks about. Excuse me.
Which is stellated tetra as well, yes.
Right. And this thing, if it's vibrating and rotating very fast, ends up looking like a sphere. Okay. So each of these spheres, you could say they're you know, this embedded star tetrahedron fluctuating around.
And the point Nassim made there was that when that star tetra, which is also cube octa, which is the stellated tetra, which is the far right-hand picture there, when that cube octa jitterbugs, suddenly then it becomes icosa. And only then do you get golden ratio, and therefore implosive compression.
Yeah. So
that's the reason superconductivity exists. Both Nassim and I talk about that. Yes.
Yeah. So that's what's fascinating is when you start looking at the structure of space in this way with this platonic geometry, and it comes from the Buckminster-Fuller isometric vector matrix. That's this IVM.
Who taught me the jitterbug personally?
Yeah, you mentioned that. So what's interesting is, Buckminster-Fuller, well, Nassim completed his thing because it needed a phase inversion, and he put two of them together. But anyways, the cool thing about this is, if you use a matrix like this, supposedly it's the only matrix that allows for Newton's equations to balance. For every force, there's an equal and opposite force, or action reaction. This is the only structure that allows, in a 3D space, that allows for those forces to be balanced.
I think Bucky called it tensor equilibrium. And what he meant
that's it.
The opposing tensor stressors were balanced, but he's saying, actually, according to Bucky, the tensor equilibrium in 3D space had more structure stability in the ecosa than it did in the cube octa. That's Bucky.
Yeah, I'm sure there's a lot more to it than that. To me, it's fascinating enough to even be able to start talking about the structure of space. And then you say, well, how does this help you? Well, there's a handful of problems that, and Harriman looked at with Rauscher at the Einstein's general relativity, and they came up with the scaling law of matter, and and explaining how black holes
That's Golden
power
ratio.
the universe. Yeah, and
Well,
it's
and that
fascinating stuff. It actually even explains, in my mind, ice crystals, the property of water. Water is a mystery to the mainstream, and this approach really sheds a lot of insight into
yeah,
what's going on.
hydrogen is at the center of water, and we now know that's golden ratio. And Bucky's way of teaching that was he would take that cube octa, the far right picture, and he'd prove that it's floppy. It wasn't stable. But in other words, the amount of material you put in cubic structures architecturally is never going to be as stable as you take the same thing and put it in the Icosa geodesic. That's the original Bucky Fuller geodesic dome. More stability
Yeah.
for less material, which eventually becomes Buckminster Fullerene, which is
Yeah.
all golden ratio based.
Yeah. Well, I'm going to go back to where we were here. And okay, so now that we have the density of the vacuum, and there is an underlying structure, superfluid structure, with that density, like we said, I'm going to call it an ether, biocrystalline superfluid. I call it biocrystalline because there is some evidence that the consciousness embeds in the vacuum. And 1 cubic centimeter of this vacuum is 38, 39 orders of magnitude more mass than is in the entire observable universe. So that implies there's way more mass and space than that required for the creation of black holes and wormholes. You still wouldn't want to get, right now, I wouldn't necessarily want to get near a galactic black hole because that's a scalar, it's mass on top of the mass that's already here, so I don't think you want to get close to one of those, but still, even though we have this huge vacuum energy density right here, it's just incredible what it implies. So we're already wormhole connected. The space may be full of microtubule wormholes. So from this assumption, we can get some answers to a couple basic physics questions. And there's, for the mainstream, there are some things that support the existence of the vacuum energy. These are some of the more clear things, which is the Casimir effect and the dynamical Casimir effect. And that's where, and I think it was about in the 90s, they actually did an experiment where in my industry, the semiconductor industry, you can really planarize things really well now, like the wafers. Well, they took some metal plates or something and made them really flat and put them close to each other. And there was a net inward pushing on the plates, and it matched the theory. So, and then there's a dynamical effect where a rapidly moving mirror that turns virtual photons into real ones. Well, you have to be moving near the speed of light. Well, you can't move mirrors that fast, but there's ways to modulate a characteristic of, say, a transmission line or an optical fiber so that it behaves like it's moving really fast. And they've actually pumped microwave RF photons out of the vacuum. And
Oh,
and since, yeah, go ahead, Dan.
that might be optimized by a phase conjugate pumping, perhaps.
Yeah, because we need to figure out some way to heat up our tea, get some energy out of the vacuum. So
Bearden always says, treat the nucleus with a phase conjugate pump wave. That's Bearden says.
mm-hmm. And a couple other things I want to mention about this energy. It's the 0 point energy. It's not free energy, as Dan's mentioned, but there's experiments in the mainstream where they're getting excess energy, and I'm not going into that real deeply here at all, but I just wanted to reiterate that from your class last week. The excess energy that's showing up in these experiments throughout the world, like the Pons and Fleischmann, the Rossi stuff, it's related to this vacuum energy and coherence and things like that. It's a real effect, whereas the mainstream, well, they're starting to accept it, but there's some basic.
You might call it constructive charge collapse or implosive charge collapse, because that's what isotope transitions are, what alchemy is, and what cold fusion is. And implosive charge collapse might be well described in what's happening between the Casimir plates as well.
Yeah. So it's fascinating stuff. So let's see. We already went over this page. This is how I'm relating the sacred geometry is by looking at the basic structure of the fabric of space and showing that everything really can be and is built up from these Platonic solid ratios. The phi ratio shows up when you pick a coordinate system where you name the vertices, label them on these primitive tetrahedron shapes, label the coordinates as 1, 1, 1 at the vertices. By the time you build up these other shapes, the phi ratio starts showing up in the coordinate points here. So once you see that, and then in nature, just so much in nature is built up from this.
In fact,
That,
if you took the infinite stellation dodecaecosa infinitely, the x, y, z coordinate of every vertex infinitely is a simple exponent golden ratio, as are the radii of hydrogen.
right. Yeah. So knowing that, then as Dan's discovered and found out that you're using Planck length times golden ratio, phi to the integer powers, Planck time, and then Harriman's added in the Planck mass too. So let's move on here, and just here's a couple of examples we've gone over where the phi ratio actually works. So with planetary orbits, I've only done a few of them here, and a friend of mine, I think he worked his way out to Mars. I mean, mathematically, and a lot of the planets follow this. The yearly orbit is a Planck time times phi ratio to the n. So the Venus year, you put in n equals 240, and it's
Those were my discoveries, and that
yeah.
was all my discovery on that page. Yes.
Right. Yeah. So I copied this from here. So this is Dan's stuff. I just wanted to show how I'm checking the numbers and checked that one. There's a few other ones I've checked, but then here's the photosynthesis equation. So I'm independently checking these out. So I copied this from your work. So I put in the wavelength of the light. This is your equation is the Planck length times phi to the n. And here you have a chart from some other researcher who showed the wavelength on the x-axis of the light, the photosynthesis rate on the y-axis. Well, you need violet light to get really good photosynthesis reaction rate, and some red, but green. The plants reflect. Yeah, the plants reflect green. They don't want green.
Because it's opposite to conjugate. Yes.
Yeah, which is implied by to get green, you got to put in a non-integer. It's right in the middle. Say it's 180 degrees out of phase. It's the wrong phase.
Which means it prevents charge distribution, prevents charge collapse, prevents phase conjugation, so it's opposite to life.
Yeah. So this is, to me, it was just more evidence that these equations have validity and give insight into what's going on in nature.
And I discovered everything on this page, I discovered simply by thinking about the fact that Planck had to be the universal key signature of the music that made life and distribution, and then just applied it.
Yeah, it's fascinating stuff, Dan. It gives me
That's
more
what my
confidence.
whole book is about, really.
Yeah. I appreciate the copy of the book too. I have it sitting here somewhere.
Biologic negentropy is the origin of non-destructive phase conjugate collapse because the phase conjugation makes it negentropic, and therefore alive, because it puts the waves into perfected distribution at the center, which is Planck, which is the universal radio there.
Yeah. So it's amazing. So even right here, I snapshotted. These are Google. You can use Google calculator to do these things. You type in Planck length times phi to the 136, and it gives you these numbers.
So it's great that Mark set up the Google mathematics spreadsheet to confirm all those equations I worked on so hard. He made it so easy. That's great.
Yeah. So now, again, we get to the question of what is mass. Again, it's the main question CERN with the Large Hadron Collider is attempting to answer. And one of my favorite physicists is Feynman, mainstream physicist. He's a logical positivist, so yeah, interesting point there. But Feynman says you can't say A is made of B or vice versa. All mass is interaction. And that's related to what we're saying. It's a vibration in the fabric of space-time. And he also posed a question is, why are all the masses of the various particles, such as quarks, what they are? Well, we're going to talk about the proton. The quarks may be a manifestation of just the way of looking at the proton. So we don't have an answer to that, but we can talk about the proton and then even the electron somewhat, even though I think the electron needs to be redefined. But so all these numbers have no explanations in these strings theories, absolutely none. And that's one of the complaints about string theory, is it's a mathematical theory, but it's not rooted in any natural analogy or explanation. And
we could mention in psi perception of quarks by Phillips in England, he showed 3 ANU per unit quark, which is the ANU is that 5-7 perfect symmetry slip knot, and so which is occult chemistry. The clairvoyants kind of saw the geometry of the quark, and then of course Garrett Lisi's E8 theory maps all the subatomics based on a golden ratio E8 perfect nesting, and then Valerie's friend Richard here, he has a slip knot model of the electron symmetry. So there's lots of people working on symmetry models of these things.
yeah. So then I paraphrase from reading a lot of Feynman's books. He's said or implied someday possibly equations will be found for these masses and simple fundamental constants, which is the Planck constant dimensional terms and geometric ratios. Well, that's exactly where we're going. That's what Harriman has done with the proton in black holes. So we can talk about the mass of the proton. The electron, at least we can use these ideas and kind of tie the mainstream together to show their results are consistent with Harriman's on these mass values. And it'd be nice to extend this to all the other particles. That's one of the first questions my friends ask me when I tell them about this. Well, does it work for other particles? Well, we'll have to see. I mean, some of the particles they want to know about may be illusionary, made up experimental things. So
it's just interesting. When I first went to visit Elizabeth Rauscher at the Lawrence Livermore Atom Smasher 30 years ago, we started working together. It was because her stated dream in the fundamental physics group was to derive all the fundamental constants of physics from pure geometric ratio constraints, you know, so it started the dream.
Yeah, and this is fantastic stuff. So one of the inspirational things I got from Feynman was he was a good mathematician, a problem solver. He says, know how to solve every problem man has solved. And then you say, well, but then let's say you're trying to, it's impossible to read all the scientific publications. So how do you keep up? And this is where Feynman really helped me out. He said, focus on the unsolved physics problems. And there's a list of them here. And that's how I stumbled across the proton radius problem. Was I knew that there are certain fundamental things you want to just keep your eyes and ears open for. And instead of reading all the literature, when I saw the Scientific American cover in January, February 2014, they mentioned this proton radius problem. And that's, since then, I've been diving into it with Liz's help, and we found Harriman's work that I think resolves it. And from Harriman's work comes this proton-electron mass ratio that I derived, and we'll talk about that in a little bit.
And so somewhere in the middle of that, you might trip into figuring out why an object falls to the ground.
yeah, and that's running into your work. As soon as
but talk about simple fundamental physical problems.
Yeah, I know. As soon as we can get an equation to relate that, I mean, that we're getting there, I think. So I listed the Planck units again, mass, length, and time. It's interesting how it's not exactly the same ratio, but the G or C in the numerator, denominator, but similar form. You got C to the first power, C to the third power, and C to the fifth power. It's just kind of interesting. Don't know what that implies yet, but well,
you derive the Planck length from the gravitational constant, the speed of light, etc., and the Planck's energy constant. So you take them in a simple equation. Once you have the length, you can derive the time, and vice versa. So just rearrange the constants, you get all the Planck variables.
Yeah. Okay, so
dimensions.
the importance of this question and it's understanding mass gives us more of an idea of the behavior of nature. And when I think about the vacuum energy and the isometric vector matrix, Hermann's way of talking about with the sacred geometry, the flower of life resonances, and the superfluid ether, there's a lot of it gives you a way to think about how things may be behaving, and even why the speed of light is a limitation, because imagine if you're pushing through a superfluid at the speed of light, and that's a limiting times or rate for interaction, so you might actually be getting some pushback from the vacuum, and that could be why they say that the mass increases as you approach the speed of light, and things like that. So the pushback, it gets harder and harder to go faster. That's diverging from what we want to talk about here. um, it also gives us a way to think about how matter and energy behave. And Hermann's pointed out that the black holes are actually it's a black hole white hole dual toroidal space-time dynamic. And I'm just hoping to inspire people to research it some more here. We're not going to go into this real deeply here. We're just going to do a couple examples of, say, how to calculate the black hole mass radius relationship. And so ordinarily we're talking about mass. It's a density times a volume. I'm mentioning this simple equation because we're going to use this to get the black hole relationship. And,
Well, and if we say that a black hole is a dual toroid space-time dynamic, essentially that means it's two vortex or two pine cones learning how to kiss noses, which supports the idea of a phase conjugate model. So again, if you just visualize the opposing vortex kissing noses precisely, making the white hole black hole. That's what you
right,
mean.
yeah.
Dual toroid.
Yeah, and we're trying to do a simple surface glancing analysis here, because I do have the Hermann's papers as a reference at the end. It's really good to dig in to see exactly what he's saying. I'm just pulling out some of the simpler things to say, hey, he's really got a point here. And so what I'm showing here is like an example of how much mass is 1 liter of water at 3.4 degrees Celsius. So if you had 1 liter, it's about 1,000 milliliters per liter. Water is defined, this was an early definition. These things are changing the more precise things now, but 1 milliliter of water was defined as about 1 gram if it's at this temperature. So 1 liter would be about 1,000 grams or a kilogram. And I just mentioned this because the next step, let's see, yeah, we're going to show how to solve the black hole mass radius relationship, and we'll get this with this simple approach. We're going to get the same answer as the Schwarzschild radius from general
Mark,
relativity. Yeah.
Mark, can we take just a second here, if it's okay with you? But see in the chat window there,
Okay.
Tobias and Jennifer have said something very interesting there. So Tobias is pointing out that the ratio of electromagnetism times to gravity is about 10 to the 39th power. So there's a beginning of a conversation of the ratio of the power of gravity, the power of electromagnetism. Now, if we could derive that from geometric considerations, we'd be moving along our little challenge there, perhaps.
Yeah,
So
that looks
that could be
really
a little
good
clue
because
there. That's a fun
yeah,
thing.
yeah,
And
those ratios are real important. That the strength
yeah,
of gravity is so weak, and these ratios are very similar to some of these big number ratios we're going to talk about, and it may be able to fall out of this analysis if we just put a little
yeah.
more
So thank
time
you,
into it.
Tobias. That could be a little clue. And then
Yeah,
Jennifer
thank you.
said Planck impedance has the same numbers as the speed limit of light, except it is in ohms. Planck
Yeah,
impedance.
that's the yeah. You can rewrite these and get like 137 ohms for the resistance of it's transmission line theory, electromagnetic theory. So
Ah,
yeah, she's right. There's a way to to look at it as an impedance as well. Yeah.
So, but the resistance then determines the speed of light. And I know if you arrange, spheres where they touch each other and then you hit one at one end, the transmission is infinite. Whereas if they're spaced out a little bit, the transmission is slowed down, which is impedance. So, and that might be the difference between the cube octa and the Ikosa-Golden ratio nesting or perfect packing. So fascinating clues there. Thanks, guys.
Yeah, thank you. Yeah, we'll have to see who can get to the equation first that relates gravity and electricity.
Exactly.
Okay, so on this page, what I'm presenting is, I just went ahead and wrote Haramain's equation for, this is mass sub S, that's the Schwarzschild mass of a black hole. And we're going to relate it to a Planck mass, which we defined earlier, and then Haramain's two terms, this R term and eta term. And he showed how to derive that, but I'm just going to start from his equation, say what the terms are, and show, okay, well, let's just do it. The R ratio, his R term is, V is the volume of the black hole in question, and then V sub LS is the Planck spherical unit volume. So you just plug in these equations, real simple geometric things, and we'll do that on the next page. Eta is the area, surface area of the black hole. So you use the surface area would be, let's see, 4 pi r, the radius, the Schwarzschild radius squared is the surface area. And then you need to divide that by the equatorial cross-sectional area of the Planck spherical unit. Now, this one comes from the information theory, whereas the first one's a geometric argument. I'll go to that in a second. So if
maybe
you could
zoom in just a little, zoom in a little bit. Yeah. Sorry.
A little. Good. So these two ratios, you put them in out. The first one, I'm gonna look at R times Lm, just this part here, put in some of these equations, and what I'm pointing out here is this term right here is the density of the vacuum that we already talked about. It's the Planck length over the Planck mass. So this term here would be a volume times a density gives you a mass. However, that might be the holographic mass, but that's not the mass. It's too big of a mass if you look at it just that way. But the eta term, which is the area, the surface area, we'll bring this over. The surface of the sphere divided by the equatorial cross-sectional area. That's the ratio of it's like the information flow in and out from this plane to the whole surface of the sphere. Well, when you put that eta term in there, and it's took me a lot of research to figure out where Haramain came up with this, but the best thing I can see is it's related to the holographic information theory part, and that's where Leonard Susskind and Stephen Hawking, a lot of these guys have been arguing for years. They're saying that information is stored on the 2D surface area of the black hole. Well, that's the surface area we're talking about. We're just dividing it by the cross-sectional, equatorial cross-sectional area. Simple arguments, you could even say, without studying the theory deeply, you could just say, well, here's simple geometric arguments. Well, what happens when you do that? Let's go to the next page. Take Haramain's equation and actually fill in, the geometric arguments for all these things, and you get exactly the Schwarzschild solution. This the mass of the black hole is the radius of the black hole times the speed of light squared divided by 2 times the universal gravitational constant. Well, this is the same answer you get, and I've seen Susskind do it. You can find a YouTube video where Susskind derives this equation. Takes him a little bit more. It's still relatively simple, but he derives the same equation. You can find it here on Wikipedia. So this was the first thing when I got excited from Haramain's, like, wow, he's got that. That's cool. And so then he goes.
Mark, before you But that picture you have, the green sphere, back one more. So it's the area of the circle of the perimeter. So you got the area of that circle of perimeter as a ratio to the
Surface
area
area.
of the surface
Yeah.
of the outer sphere. So it's like
Yeah.
from 2D to 3D in a way. And
Yeah. In a way,
oh,
yeah, it's 2D to 2D, but it's almost like the inside to the outside, you know.
you map the center of the circle, the area of the circle, to the area of the sphere, basically. But all I
Yeah.
can think of is after the Paris talks, Nassim came up to me. He says the fun part is because if you Penrose tile Planck dimension onto the sphere of the Schwarzschild proton, you get the ratio of the Schwarzschild proton to the conventional proton.
Yeah, it's really fascinating.
It's fascinating. So it's pure geometric origins of these things. It's so powerful. Anyway.
Yeah, yeah, and we'll see that this is the black hole argument. We'll see the proton argument, the same type of thing here real soon. So I just want to mention a couple comments here. Again, what we did was it's a geometric argument. Density times volume divided by the information theory factor. And just to give a little bit of insight, and this is an analogy and a note, analogies fall apart quickly, so we want to focus on the phenomena. But this is similar. What we're talking about here is, let's say we had a plastic 1 liter bottle. We filled it up with water. Say the water is about a kilogram, 1 gram for the plastic bottle. So if I lift that out of the ocean, it's going to be 1,001 grams. But in the ocean, since we're surrounded by water, it's going to be about a gram in the water. And these are approximate. But that's kind of what we're talking about here with the black hole analysis. It's the idea of in the vacuum of space. The vacuum of space is so huge, so dense, that if you calculate these volumes and use that mass, you get way too big of a number. Well, it's floating in the vacuum and it balances everything out. So that's why the information theory brings it down to a more reasonable value
That's the
for
way
the
Nassim
actual.
That's
Yeah.
the way Nassim explained it as well. That if you had the real proton embedded in the ether, then it's the small dimension of the proton. But you pull that same proton out of the ether, and it would unpack to the dimension of the Schwarzschild proton. So it's
Yeah,
the
and then
exact
it
metaphor.
and then it weighs a huge amount. And if I
Right.
recall right, that's where him and Elizabeth Rauscher kind of got in a little bit of an argument, because he's claiming these
Yeah.
huge masses. Well, it is a huge mass. You just have to look at it the right way.
But the key thing is that if you pulled the regular proton out of the ether and examined it out, take the drop out of the ocean, then it unpacks hugely. That's the
Yeah, yeah, and he has a long conversation about that. We're starting new dimensions and things. And
mm-hmm.
the other thing is, let's see if we go ahead here. The proton, yeah, the proton mass. If you don't count the information theory part, or all of the mass of the weight of the proton is equal to all the mass of the observable universe, and that's a clue that we're actually fractal, embedded, and connected. That's why they're
It's sort of like
saying,
somebody saying there's only one proton, it just gets around.
yeah, and they're saying that it's like hollow fractal graphically embedded. So if all the universe is embedded inside one proton and they're all connected to all the other protons, it just starts making a lot of sense to me. So let's do the analysis of his equation here. This is Haramain's equation, the geometric form. And though it's the same R term and the same eta term, same Planck mass, this time it's the inverse ratio, and there's a factor of 2 in there. And again, instead of worrying about the derivation of the equation, let's just see how it's applied and see what it tells us. The derivation can be pretty extensive, but geometric argument, it works out. So again, the R term is going to be the volume of the proton, and we just say, oh, it's 4/3 pi r cubed, and then we're going to divide that by the volume of the Planck spherical unit. And eta, again, is the surface area of the proton, and again, the equatorial cross-sectional area of the proton. And same terms. So we're gonna, instead of going through all the math, we'll just go right to the answer. You plug in all those terms and you get the mass of the proton times the radius of the proton is 4 times the Planck length times the Planck mass. And this is Harriman's algebraic form. I like to rewrite it in this way here. It's the Planck mass divided by the proton mass. So it's dimensionless. Then you get a radius divided by 4 times the Planck length. And that's dimensionless too. Well, let's talk about this, to show how accurate it is. I mean, it just looks pretty simple, but why these terms on the left are already so-called known measured constants, like the Planck mass is the square root of the Planck. Let me see if I can bring that.
They're very accurately known. Yes, yes.
Yeah, very accurately known constants. The speed of light, the
Mm-hmm.
universal gravitational constant, and the
Precise.
Planck's constant there. So you put in those values there, the measured proton mass, make this ratio. Well, this is from a constant. The only number that works for the radius is this 0.84126 femtometers, which is 4% less than the mainstream accepted value for the proton radius. So this equation by itself, if you can solve for the proton radius, just put it all over on one side, you get this number. Well, this alone predicts the success of Harriman's approach, and yet people still question it. So what I did was, well, in 1990, around 1990, I was working on solving for mass. A friend of mine said, "Hey, can you solve for what is mass?" I used the Schrodinger equations and different wave equations, but I needed the proton radius, and this was,
and here 20, it is.
Yeah, and here it is. And it wasn't until 2010 and 2013 this data came out.
And you should say that the muonic hydrogen is the Schwarzschild proton. That's the point, right?
Yeah, well, the muonic hydrogen, instead of using an electron, they use a muon to make a hydrogen atom with a proton and a muon instead of an electron. Now, the lifetime of the muon isn't very long, so it's kind of hard to get these to set up, but it's just like building another atom of hydrogen with a muon instead of an electron. From that, they can measure the resonant frequencies when the electron jumps from one band to another, and they were able to extract the proton radius. Well, they were intending to refine the codata values, and they got this number, it's 4% off. Well, Harriman had predicted it in 2009. He did update his paper. But I want to go on and show, just real quickly here, I'll get back. Similar approach to calculating the black hole mass. It's an energetic vibration, and we're gonna talk about torque and how the proton and electron are related. So I want to skip to this next slide here. The proton electron mass ratio. I took Harriman's equation, and then this
Harriman's equation for the Schwarzschild proton.
Right, yeah, Harriman's proton equation. And then there's this already existing Rydberg equation for electron mass. This is the easy way to derive it. You can use these two equations and get this. This is the new equation up here that no one else has. And there's papers where they got all kinds of attempts, 20 different, whole bunch of equations. They don't get this number. But if you plug in Harriman's equation, use this equation, you get this alpha squared, which is the fine structure constant. That's a well-known physics constant. It's a ratio of all these other known constants. Pi, of course, everybody knows that. Then the Rydberg constant, that comes from this electron mass analysis. Well, this is a real simple equation. Well, people have been wanting to know where they knew from the mass of these proton electron measurements, it's supposed to be 1,836.15267, but they never had an equation or knew why it was that.
Pure
This is,
geometry.
yeah,
Mhm.
yeah, for geometry. And this is the first equation that exactly gives the number they want, the need. And it only works with the disputed proton radius value, which Harriman came up with.
But no,
So,
the NP above there, mass of the proton, that's conventional mass.
right, yeah.
Whereas the R sub P down below there, that's the non-conventional from Nassim.
Right. Well, that's the radius. It would be because it's a mass radius relationship. So that is Harriman's radius is needed there, but that is the conventional mass over here on the left.
And the point you're making is only by plugging in Nassim's radius do you get the correct answer.
Right. Yeah. And one of these days I'm going to get the time. This took when I was 28 or 29. I went through this derivation. It took me weeks, and I had to put it aside. But I'll derive it again to show I can derive Harriman's equation from classical arguments. I want to do that. Haven't done it yet, but I'd like to see, or maybe someone can beat me to it. But this equation I derived before got this in a whole different way, and so I want to go on and show that how clearly this proves the equations are correct. Here's the proton radius that you need. No other equations exist or have been derived until now for this. Many attempts, and requires new thinking. And it shows that the isolated reductionist approach is incomplete. That's the mainstream. They like to tear things down, break things up with
It
an
shows that
electron
pure
collider.
geometric embedding is the cause of the ratio of the proton to the electron, meaning that embedding is what holds them together. There has been no pure geometric solution before.
Yeah. So then let's look at this equation a little bit more. You can rewrite it and solve for pi, same equation, and solve for pi. And the reason why I do that, because pi is kind of well known. And notice in the denominator is Harriman's proton radius. And the rest of these terms, we can use values from the mainstream. So RP has to be exactly this number, as Harriman's saying, for it to work. And we go to the next page to see a curve of this. And what I did was plotted this equation, made an Excel spreadsheet for pi, put in all these constants from the mainstream, and my variable on the x-axis is the proton radius. The y-axis is the squared error, or deviation from pi. So when the error is 0, let's zoom in, the error is 0 only when you put in Harriman's value for the radius. If we use the mainstream value, there's a slight error here. It's about a 4% error. So even this geometrically, when you get an equation this simple, I'm surprised people just know, whoa, where'd that come from? And want to see the whole derivation, because there's a lot of papers and a lot of thinking that go into this. This helps to build the case that Harriman's right. Like I said before, with his simple equation, you could show it's right. But then when you take it further, this is a long, outstanding ratio people didn't know related to a simple pi. And so, yeah, it has to be his value. This is what I'm trying to show here. And so to me, this is really, really fascinating. So I put this up on Wikipedia too, not this pi form, but the other
And just
form.
to understand your equation there very well on top, Mark, so underneath the bar, you have radius of the proton from Nassim. You also have the mass of the proton from Nassim, right? M
Right,
sub p.
yeah. And Nassim's mass of the proton totally agrees with the mainstream, except for he has an equation for it and they don't. They just measure it.
I see. So that is conventional also, right?
Yeah,
So
yeah.
it's the radius that's new information there.
Right. So that's the joining point. If you really think about, how do you join the Sims work with the mainstream? Well, he's all mainstream except for his radius, and then you look at his argument, and his argument for the mass of the proton, and that really should
And the fact that this equation works is evidence.
yeah,
And also intuitively, if we understood Rydberg's constant better, we could understand the geometry. But that might be beyond the scope of this conversation. But I'm sure it's profound even to think about what Rydberg constant really means there.
yeah, yeah, and that's something I like to study more. Is I really think that the electron has to be reworked, because that Rydberg equation is an empirical equation. Let me see if I show that. Yeah, this one right here. It's basically where they have a theory and they do some measurements and then kind of curve fit, and then they have a lot of the mainstream constants here, as we can see, but then they come up with a whole new one. That's the mainstream. They always need new constants to get things to fit.
That's for
So
the
even though,
mass of the electron, right?
yeah, the
Yeah,
mass of the electron.
because Valerie's friend here, Richard Gautier, has been working for years on a model of the symmetry of the electron as a toroidal slip knot. And so it'd be fun to try to apply that sometime. But also, translation of vorticity on the surface of the torus, same thing as the fine structure constant. The
Yeah,
geometry that you work in the electron.
yeah. So this was exciting stuff. All my life, when I studied Tesla and all these different guys like Faraday, they get their names to an equation. I always want to come up with an equation. Well, here's one I came up with. My name's not on it yet, but
Let's call it the Rohrbaugh equation, of course.
yeah, we'll have to publish officially
Definitely.
or something.
Let's do it together. Cool.
Yeah, yeah. So let's see where we were here. I really like this equation, this thing here. So that's basically just, you can look at the equations and do some quick calculations, but I wanted to show graphically that, yeah, we're putting numbers to stuff, and getting real results here.
Pure geometric solution.
Yeah.
The mind of God.
Yeah. So then, months went by, and I said, well, hey, what else can I do with this? And I looked up, because I used in chemistry Avogadro's constant. That's very important number for when you're doing chemical reactions, molecular weights, mass reactions, and calculating products and reactants. So I found the mainstream equation and just stuck my ratio in there, and you end up getting just a slightly different number. Here with my version of it, it's way out here, you get a 1 instead of a 0. I don't know if there's much here, but I just wanted to show that. And I have done a search on the literature, and sometimes I've actually found this value for Avogadro's out there on the internet. There's different
So you
numbers.
corrected Avogadro.
Yeah. Yeah, this one I want to do a little more work on to find out if it's better or if it really matters. It's so far down, but it is slightly different. And this could be related to they're working on redefining the mass, or the way to measure the mass, instead of having, like right now, it's some sort of silicon sphere that weighs a certain amount, but it, oxidizes and the weight changes, or whatever happens. So they want to come up with some other way to measure the mass, a universally accepted way. And I'm thinking this stuff might help out with it, some of this work. So there's some other areas for people to look into if they want to make an impact in this work, is figure out how to define the mass with a electrical type measurement, or some sort of measurement that's consistent with everything else, So
It's beautiful. You can rewrite Avogadro that way, but again, pure geometry.
yeah. So, and here's where Liz helped me out with this. We want to talk a little bit about the left side of this is Haramain's equation. I'm using capitals, with the mass of the proton times the radius of the proton is equal to 4 times the Planck length times the Planck mass. So that's his new equation. Well, when I was deriving this stuff using Schrodinger's wave equations and some other calculus tables years ago, I was actually working on solving that proton-electron mass ratios. My high school chemistry or calculus teacher told me about it. By the time I got out of college, I said, let me give it a try, And I couldn't figure out. I had two equations, I had to equate the proton to the electron. So this is the radius of the electron times the mass electron. Well, when I was talking to Liz and she pointed me to Harriman's work, and I know how he's adding torque and Coriolis to Einstein's field equations, and he solves for dark matter, or actually he eliminates the need for dark matter and dark energy
Good.
when you add spin and Coriolis and all that. So here Liz was saying, hey, let's just equate them, because the proton is, you know, a spinning vibration in the vacuum of space, and it's being fed by and balanced by the electron. So with that argument, she says, let's just equate them. And when you do that, and using these other, the Schrodinger wave equation, out comes three different ratios. And this is the stuff I did in 1990. Didn't realize how good it was. And I'm saying there's one other number, which is 1. So it's 4 different numbers. But it's basically the proton to electron mass ratio comes out. Again, I'm just repeating here. I didn't know at the time. I plugged in the code data value for the proton radius, and this was off, 4% off. I didn't really realize that it was 4% off. I just thought the number's not right. My analysis must be wrong, but I saved it anyways, and Harriman's equation comes out of it, the Planck length or Planck mass to electron mass. This is just part of a theoretical analysis of it. What am I trying to say is that the main thing I'm trying to say is when you write the equations this way, a lot of these things fall out, which are interesting numbers, but the only main point is that Harriman achieved a lot by adding spin, Coriolis and torque. And this equation looks so much like a torque equation is what I'm trying to say here. Is if we take a torque equation, that's a radius times a force. Well, what's a force? That's a mass times an acceleration. So a torque would be a radius times a mass times an acceleration. So I'm putting a box around the radius times the mass times, radius times the mass here, balanced by the electron radius and mass. So I'm just trying to point out, I think these are some important ideas that it's related to some of the arguments that really help Nassim get some good answers. So I actually mentioned this, not in this much detail, to Nassim in person, and I was talking about this torque mass thing, and he's like, hey, that's really good. This is when I first met him, so.
Mark, Jennifer's asking if you'd zoom in again on the stuff on the right, just so you can see it.
Yeah.
And, yeah, just one more look there. And I really like what you're saying there, because what it says is that we could understand then the proton to electron ratio by simply imagining how the electron is nutating and precessing in a planetary orbital around a sun of the proton, basically.
Yeah, and it's hard to say if it's rotating. I think it's blinking in and out of the vacuum. It's annihilating and creating it. The electron is.
Remember, where longitudinal waves cross, they form again transverse at a distance, which creates plasma containment at a distance. So the whole thing is basically the convergence of longitudinal waves, which is how Bearden says the proton is created. It's a phase conjugate pump wave. So when we say blink in and out of the vacuum, what we mean is the place where phase conjugate pump waves reconverge. And that's where you get Foo Fighters and plasma occurs out of the vacuum.
Yeah, and all this stuff, I'm attempting to go from a mainstream approach to some new stuff, but a lot of it I think needs to be redefined. As soon as we get to talking about things that are in our minds that we can't observe directly, that's when, you know, you start getting one step away from reality. And
But how beautiful it is that Bearden is saying a phase conjugate pump wave is why the nucleus exists, and we're saying the reason your mind can hold a flame, plasma, the flame in the mind, is where a phase conjugate pump wave converges. It means that basically phase conjugation creates a centripetal force holding the plasma in one place called mass and mind.
yeah, yeah, it's very interesting stuff. So some of the other details on here was like I said, the electron mass and electron radius. I have a term for electron radius, but it's way too big. And that was one of the problems that Harriman got in, was that some electron radius is too big. I think it's because the electron has to be redefined, you know.
I wonder
So,
if
yeah. Oh, it's clear now.
Richard
So,
Gauthier. But just note that Jennifer's note here that she sees a lot of 4 diameter of Planck to meet the Schwarzschild condition, and you have 4 LM there.
yeah,
Jennifer's chat.
yeah,
Interesting.
yeah, it is. 4L comes in a lot. It's probably like related to surface area, you know, 4 pi r squared or 4/3, the volume 4/3 pi r. Yeah, there's geometric stuff in here. The pi shows up as well. So there's a lot more work to do to figure out the implications of this stuff. It's when we get answers, this is the beginning. Then you got to, like, when I saw Harriman's work and I pointed it to a few other scientists, I thought, boy, they'd dive into this, because it takes a lot of work to take this to the next step, you know, first accepting it, seeing if it's right, and then seeing where to go with it. And there's a lot of room for growth here. So let's see what we got
And of course, the
next.
Tetris part of it too. So
Yeah. So here, just some more examples. I wanted to check Dan's work out where you talk about the ionized hydrogen radii. So I looked that up. You know, here's your equation for the Planck length times 5 to the n. Put in 116, 117, and 118, and you get, I looked this up in a paper, you get the different ionization or radii of hydrogen, you know, the different levels of energy, first, second, third. And, you know, the literature showed 0.28, and your calculations really close, 0.46, really close there if you round up. And then they talk about the third one. They got the 0.74, 0.75 from different measurements, and 0.74 there. So I really think your equations are really valuable to give some insight into
it
what's
would be
going on.
appropriate to mention a little history there, because Hayrovska, in my original paper on this, Hayrovska had found golden ratio all over the geometry of hydrogen. The paper was goldenmean.info/golden proof. I'll put the link here. So Hayrovska had shown that those radii were golden ratio to each other. So the only thing my intuition was, oh, they must also be golden ratio to Planck. And that was,
Oh,
so that
okay.
was my new information. Was, see, he knew they were golden ratio to each other. And I said,
Okay.
oh, they must be embedding in Planck. And then I checked and I was right. That's
Yeah, very good. That's really good stuff. So that's, to me, it's just fascinating. It's like I'm learning all this new stuff by breaking away from the mainstream, you know.
Planck is the conjugate point. That's the 0 point. That's where the charge reconverges phase conjugate and achieves charge distribution with the vacuum. And that's why you also get neg entropy there. And that's another conversation.
Yeah. Yeah. So very fascinating stuff. So here's some of the new slides. I guess I might be going a little bit fast this week. We can always have more conversation near the end, but here's some of the new slides I added this year, where I want to mention the thing that's accepted is we have 4 fundamental forces of nature, and that's the present known science viewpoint or belief in the mainstream is that gravity is the first one we all knew about, you know, with Newton and all that, or we could even sense and feel. Then there was the electromagnetism. I mean, people always play with magnets and static electricity, but then it was in the 1800s we were actually able to use this, once we understood it better, use it to develop electricity and get it to do some work for us. Likewise, in the 1900s with the strong nuclear force, the weak nuclear force, this is related to the atomic theory and the bombs and all that stuff. So once they learn how to harness that stuff, well, of course they go to war with it instead of helping us out. But
There's the
then,
problem.
yeah. So then you say, wait a minute, what's really going on here? Oh, this paper is reviewing Haramain's papers. I have the references at the end. At the end of his paper, I didn't mention this at the last class, is he actually shows the strong nuclear force, and that's what we're going to talk a little bit about now. Strong nuclear force can be represented by a gravitational effect, and he gets some of the same frequency resonances and other properties with his calculations that match the mainstream. And so I didn't present a lot of equations of that. We're going to talk about that a little bit. So if he can actually replace the strong nuclear force with gravity, which I think he can, and I just swept the weak nuclear force in there with it. I mean, this stuff is useful for when you're analyzing the subatomic, what makes up the proton, and if you're trying to smash them apart, this stuff's useful for that. However, if it really can be explained by gravity, then we're down to two fundamental forces. And then in the process of trying to figure out gravity, as Dan's doing and everyone else, and Dan, you might be ahead of everyone else, it really looks like there's one field. It would be electromagnetism, one fundamental force field. And electromagnetism, and I've read about this for years, is actually, Richard Feynman shows in his books, that the electric field and magnetic fields are projections of a single field. This is what Feynman says. And that's fascinating.
Yeah, and the fact that if phase conjugation is what makes the electromagnetic field centripetal, in the process of identifying the origin of one centripetal force, gravity, you in fact could identify all centripetal forces, electronegativity as well. So in effect, what you're saying is that the Planck dimension, Planck sphere, is a bit of a black hole, and the charge goes centripetally to it because of phase conjugation, because charge is accelerated toward it by phase conjugation. And that acceleration of charge toward the Planck sphere is named the gravity, basically. Hence, phase conjugate cause of gravity.
All right. So the ideas and the concepts we are able to talk about and make a lot of sense. The first person who can get this to math and show really clearly that it's one field to explain gravity and all that, that would probably be a Nobel Prize or something right there.
It's the Jesus dream and the Einstein dream, the unified field, which is to say the unified compressible media. And if acceleration of charge toward the Planck dimension is caused by phase conjugation, which we could prove in all this golden ratio stuff, in effect, that's evidence that that's the cause of gravity. How else would hydrogen be making gravity if it wasn't using golden ratio to phase conjugate?
Yeah. So we'll have to do some experiments and analysis to take this to the next level.
Actually, we're going to make propulsion, and we've got equation for that as well, fractalfield.com/propulsion. We intend to prove it with gadgets.
Yeah, and that's what I'm looking for, is some actual gadgets.
Absolutely.
Energy,
propulsion, hydraulic propulsion. Basically, if you put a spiral on a torus for charge, you make gravity, and that's how the Nazi Bell and the Vimana flew.
Yeah.
Yes, and Tobias is commenting that the Thunderbolts project is based on a universal plasma theory. So, and the universal plasma theory of the universe is a unified field. So, yes.
Yeah, and that's not exactly my next slide, but just want to talk about, when the one fundamental force, the electric universe, there is the electromagnetic plasma theory of the universe. There's a faction of people pushing the electric universe, and that's really good stuff. What I want to mention was, sometimes see on the internet a little battle between, say, Nassim's approach and then the electric universe. Well, the electric universe is very complementary and very important. We need that for Haramain's thing. What I'm trying to point out here is the electric universe theory. Well, I think that's really useful, great stuff. That's my main education, is on Maxwell's equations and electrical engineering. one of my college professors, Professor Restemeyer at the University of Cincinnati, used to say Maxwell's always lurking in the background. I always like that expression. What that's about is, when you're studying physics, say mechanics, where you have masses that are falling in gravity or moving or friction, that's one way of looking at problems. And then the electric problem is usually handled separately. So in a sense, that's what, interestingly enough, Harriman's done, and a lot of us do. We work with mass and matter in one way, and then electricity and charge another way. And interestingly enough, Harriman's been saying, hey, we need to wholly look at the physics and redefine it. And I'm agreeing with him. I think we also have to include the electric universe theory in this as well. So there's still a lot of work to do to get there.
That's where the electric universe people always start by saying plasma is 99.99% of the universe, and therefore, if you now know how plasma makes gravity by becoming phase conjugate, and that's our whole article, fractalfield.com/cold plasma, is that phase conjugators rotated make gravity. And another friend recently actually privately confirmed that to us here. So the reason rotating phase conjugators make gravity is because that phase conjugators is the cause of gravity. So you rotate plasma to phase conjugate symmetry, you make gravity, and the masses of the universe are known to be dodecahedrons, so it does fit together.
Yeah. And then some of the arguments on the electric universe theory, they'll say things like maybe black holes don't exist, or this certain things don't exist. Well, there's still some questions out there, and I think instead of fighting, we need to somehow look at both theories together to uniform it, to make a uniform theory. Because the electric universe, I mean, that's with the way they're describing cosmology, that's what they are, as far as I understand. It's more of a cosmological explanation, whereas Harriman adds just a little bit more, actually a lot more, gets down to the quantum mechanical stuff as well as the cosmology. And I think they're saying the same thing, but just the electric universe, I think they need to add a little bit more of the fundamental matter or quantum vacuum vibration. But they're explaining a lot, and I do need to study that some more. But I think
and just
it's
a
really
nod to, not to interrupt, a nod to Maxwell here, that, Bearden and Bill Donovan and Elizabeth both emphasize that when Heaviside castrated Maxwell's equations by taking out the fourth element, the quaternion, therefore no one could represent spin. And so both Nassim and yourself are saying it's spin that allows you to model gravity here. So if without the quaternion, the Maxwell's equations is no good for representing spin. And that's why Einstein's work with Maxwell's mathematics was castrated, basically.
Yeah, and you're hitting the nail on the head there, because I learned a lot of that stuff in college, or Maxwell's equations. Didn't realize till recently that the equations have been castrated, that they're not complete, and since then, even those equations, Maxwell's, we use limited simplified forms in engineering, and a lot of times throw out a lot of terms to be able to get answers. Well, this is telling me we got to go back and look at all the effects, include it all. And here what I've shown or written down here is I just listed some of the basic theories. The Einstein's general relativity. That's, as far as I understand, that's the accepted cosmology. Mainstream standard model would be quantum theory, quantum mechanics, quantum field theory. That's for the world of the small. And what we're looking for is a unified field theory, and that's what all this is about, going towards that direction. So,
which is a perfectly compressible media modeled by perfect geometry. And just to mention, I put that article, fractalfield.com/mathematics of fusion, where Bearden's film on what Maxwell lost there is all there in that discussion at the bottom.
Okay, good. So what I've found out as I'm studying this stuff, some comments. The quantum mechanics theory took generations to develop, and many researchers, likewise the new science that Nassim, you're doing, I'm helping out with, this is going to take the same effort, a generation or two, a lot of effort. It's going to be a reworking of all the science. And it's just basically like whenever you got your homework assignment, say a take-home test in college or high school, everybody comes in, gets a bad grade, and the teacher gives you a do-over. Well, that's basically what we need to do, is just do a do-over. Do a do-over of some of the science, especially history, archaeology, astronomy, and other fields of study. Like,
And
go ahead, Dan.
well, the do-over has to do with some of Einstein did obviously a lot of great work, but Einstein made some mistakes. He thought the speed of light was a speed limit, for example. And by calling it space-time instead of just a universal plenum of charge, he implies this the beginning of the schizophrenia of the difference between space and time. No, mass and time are both defined only by rotating charge. So that plenum is in fact the rotation of charge in the compressible media. So that's a unified way of thinking that takes you past the schizophrenia of four separate forces.
Yeah. Yeah, and even in astronomy, once we get a better way of looking at things, and Harriman's really done good on this, once you understand what's going on with the dual toroidal black hole powering galaxies and even stars and maybe even planets, we'll have a much better interpretation of what we see through the Hubble and other instruments. And what's fascinating, after I spent all the hours following Harriman's work, the electric universe, the orange theory, you can go look at these Hubble photographs and see these patterns that you see in the dual toroidal effect. And this explains the galaxy rotation problem and all that. What's interesting is black holes may be the source of matter in our universe. They're finding, the astronomers are, when they go way back in time, when they look really far away, they're seeing massive black holes that shouldn't have existed, because their theory is, after the Big Bang, things then congealed or condensed into these galaxies and black holes. Well, it actually might be opposite. We might be being taught by someone dyslexic. The big opposite of the Big Bang would be that the black holes were there, and then the matter, the protons are coming out of the black holes. Now, Sim talks about that. He does a lot better job. And so I wanted to mention that a lot of the stuff we know may be opposite of really what's going on. So it's very, very fascinating stuff. So let's see where we're going. Yeah, just a couple details, I guess.
Also had that if the Planck dimension is what unifies not just the black hole but the Big Bang, then you could say the Planck dimension and the Big Bang have the qualities of a phase conjugate mirror, which is negentropic.
Yeah. That's good stuff. So just a couple other comments here. It looks like I wanted to, at the end of Harriman's holographic, it's his paper I have down here, that's the Schwarzschild proton, the holographic mass, where he talks about gravity could be what's causing the strong force. I want to just mention a little bit about that. So on the right,
zoom in a little.
Yeah, on the right, we'll look at the right one here. This is a Yukawa potential versus radius. And I've studied a little bit of quantum chromodynamics just because I'm on the search of figuring out new physics, and learned about the Yukawa potential. And they use this in QCD, subatomic theory, to deal with forces, confining forces in the proton between the quarks and all that stuff. So they use these empirically derived or just hand wave derived, the way this potential varies with distance from the center, say, and then they get their equations to match theory, and it works all right. But it's kind of, do they just make these up? They use different values to get these curves. Well, what Harriman did with the proton was treated the spinning proton like the mass is at the surface. Maybe it's going at the speed of light, and you get this relativistic mass increase at the speed of light, and derived his own relativistic gravitational potential that behaves so closely to this Yukawa potential that they just kind of hand wave in the mainstream. And I didn't want to, this is a little bit, this is even advanced for me here, but I wanted to point out that when Harriman treated the proton, spinning proton, looking at some relativistic effects using his proton radius equation, he was able to find energy angular frequencies and periods for systems mathematically that match the characteristic gamma frequencies of the nucleons and other scientific measurements. So to me, it's a really good indication that his theory is really on to something here. Because
Huh.
this is one thing here where whenever you let the electron slow down, or not the electron, the proton spin slow down a little bit lower than the speed of light, that potential drops off so fast with radius. And it's straight from the equations. He gets this. And
Huh.
it's just more supporting stuff that you could
Gravity
probably.
replaces, if gravity replaces the strong force, and Moon is right at University of Chicago to say that the nuclear hadrons, which are the strong force and the weak force in the nucleus, the nuclear hadrons are in the symmetry of Ecosa and Tetra, basically Platonic stellations, which are to say conjugators. Then that would say the gravity is caused by the conjugation, and would emphasize that Bearden says, oh, you can get energy out by treating that proton as a phase conjugate pump wave.
Yeah, and that's what I'm looking for, is getting some energy out.
Yeah.
Yeah. Okay, so here's what we were talking about near the beginning before everybody joined. This is just showing, continuing with the idea of one force field. Well, gravity right now, this is Newton's law of universal gravitation, the modern form, where it's the product of two masses, the gravitational constant, divided by the distance between the masses squared. This is just a simplified form of it, because there's potentially more to it than that. Well, the Coulomb's law for two electric charges, this is the separation of mass and charge. If you look at charge, the equation for the force between two charges, it's very similar, the inverse square relationship constant out here. So the form of the equations are the same. And the next thing would be, how can we show, like we're discussing, uh, the charge implosion, some fraction of it, with a reasonable geometric or some information theory or probability
And
theory analysis.
and we had the intuition today that since the fine structure constant appears to be derivable from the translation of vorticity on the surface of torus, that both of these things basically are optimized translation of vorticity, which is how you name the golden spiral when you study it in hydrodynamic physics, which is to say the connection between gravity and charge.
Yeah. Yeah, and the hydrodynamic physics, the fluid dynamics, and you've talked to me
Fluid
about some of
dynamics, when
those.
you study golden spiral in fluid dynamics class, they call it optimized translation of vorticity. And what they mean is that vorticity, the rotational component, is mass, and the linear component toward center is gravity.
I got some
And
studying to do.
you put that spiral on a torus, and you pump water and charge down it, and you make gravity. And that all the equations for that, they're Navier-Stokes equations, are at fractalfield.com/propulsion in the PDFs.
Yeah. Yeah, I've seen some of your experimental work too. You have in there
Made
about.
about a gram of gravity by pumping.
Yeah.
You had a $2,000 pump pumping
Yeah.
water down a tube on a spiral on a torus. Absolutely.
Yeah. Yeah. And I believe it's possible. You even look at the NASA's EM drive that they're starting to
Yep.
be able to. They're
Yep.
showing anomalous thrust, and I think it can definitely be explained by your physics and Harriman's physics. It's
And
this.
that spiral on the torus is called the flame letter. And so when you visualize a Hebrew letter in your mind, it squirts your torus in a certain direction. And that's your vector propagation choice of inertial navigation when you're a ghost.
Yeah, so we'll have to learn how to navigate whenever we get to that point.
Don't at that point.
Okay, so we just got a few more slides here. Just some general comments. You know, David Bohm mentions on the YouTube the worldviews, and I even had to look up what a worldview is. But a worldview is a summation of like our belief systems, how we see the world, and the old worldview is in science, we should say, is a disconnected, isolated, reductionist approach. And we do that often because then you can, when you analyze a problem, you can actually get some way of analytically representing it with equations and get some answers. Otherwise, the problems get too tough. However, when you do that, uh, break a problem down into these small pieces, sometimes you actually miss the essence of the problem and destroy what's going on. A simple example might be, like a life form. If you break it down too much, it's not going to be alive anymore. So, my point is, you just have to watch out taking these approaches. The objects, what they're saying in the old world is objects define the boundaries of space, time, or space, and we have a linear evolution. Well, a new possible worldview, this is from some of Harriman's teachings, is it's a connected whole view of looking at things, and that's because we have the super dense energy of the vacuum. It's so dense we're all connected. And space time, that vacuum defines the objects. It's the vibration in the space that's the objects. And evolution is cyclical. Mainly here on Earth, it's cyclical because of life and things are changed by catastrophes like the dinosaur extinction events and other events. So it goes and then starts over, goes and starts over. So just some stuff here. This leads to a different way of thinking. Out of the box, there actually is no box. And the 2D Cartesian thinking, 2D physics is incomplete. I have one example of that it's kind of easy to understand is with our computer screens, they're two-dimensional. And let's say you're trying to represent certain special numbers just on a graph. Well, two-dimensional computer screen, it's quantized in the pixels. So you have an integer number of pixels in one axis, integer number in the other, and it's pixelated. So if you had numbers that were irrational, how are you going to show irrational numbers on a two-dimensional graph? I mean, the more you zoom in and fractuate the problem, you'll see it, but you're always going to miss something if you just look at it two-dimensional quantized thing. That you got to look at it more complete and like a holographic fractal complete. So these are just some ideas that we want to follow up on after the course. It's up to everybody to keep up doing the research.
There's a fun conversation in the chat window here, in that regard, Mark, just a second. So Tobias was pointing out that the notable feature of string theories that require extra dimensions of spacetime for the mathematical consistency. Boson string theory, spacetime is 26-dimensional, which, by the way, is the classic what's called Calabi-Yau, 26 dimensions. And we did a whole analysis of that 26 dimensions is actually the number of holes in the zone tool connector for the, and they call it 13-zone system. If you look at the white ball in the zone tool, golden mean dinitrostase kit, the Star Mother kit, each connector has 26 holes, 13 axis pairs, because that's the number of axis pairs that embeds a tetracube in dodecacosa, 7 plus 6, 7 spins plus 6 spins. So actually, the way you superpose spin rotations of charge is actually how you get this idea of dimensions. The number of dimensions you're in is the number of axes of spin you can superpose, which is Calabi-Yau, the 26-dimensional. So this whole idea of the number of dimensions you're in actually resolves to how many axes of spin of charge can be superposed in a Platonic embedding.
Yeah. Yeah, that stuff is really amazing. I was looking at general relativity with Susskind's course, and that they have, what is it, 11 dimensions right out of Einstein's work. Well, Yeah, you get up to 20 or something because of symmetry and all that. So
Yeah, it's really, people get the idea that superposed dimensions is so pure mathematical abstraction, but it's not. The number of dimensions any wave system is in is the number of axes of charge can be superposed rotating a simple array. For example, the dodeca is the fourth axis spin of the cube. You rotate the dodecadone helix. That's 5 axes spin, which is literally the thread of DNA. And then you braid the braid of the braid on top of that 7 times, and you have 5 plus 7 superposed axes of spin symmetry. It's not 12 strands, it's 12 dimensions, 12 superposed rotational spin axes, perfecting embedding 5 and 7.
yeah, yeah, very good stuff. Yeah. Yeah, I've always been interested in this extra dimensional stuff to find out how real it is.
And the fun thing is you can never superpose more than 3 axis spin symmetry unless you use golden ratio. That's what's allowed. So you can't get a cube in anything else but a dodeca, which means only golden ratio works. So you can't get to
yeah,
higher dimensions unless.
yeah, yeah. That golden ratio, golden spiral stuff is really important.
Embedding perfected
Yeah.
and perfected.
Okay, and some of the implications of the unified theory, from Haramain's approach is energy generation, as we talked about, and gravitational control, and then a different way of relating to the environment. You know, the restoring Earth's ecology, consideration for all life, and for the benefit of all to the advantage of none. I add that last one because some of the things I've read online, they say that certain agreements are made throughout history where, it's like, hey, we're all doing good, except for when you really look at it, some of these agreements are made to the benefit of certain. I think that's why we have such a high income inequality, from the highest to the lowest paid, because it's set up for the benefit of some people, you know. So anyways, there's a whole lot of new thinking that has to go into things
And just
with
the
the
idea of
new
gravitational
physics.
control there, that effectively, from the famous book, The Time Falling Bodies Take to Light, that NASA will never be able to do solid state propulsion until they know why an object falls to the ground. And in fact,
Yeah,
if you know how a spiral on a torus for charge, inertia, makes gravity, then you know what flame layers, origin of the alphabet, the origin of propulsion, a rotating conjugator. So in effect, you can't actually migrate your own aura to make lift unless you pay your debt to gravity, called getting
yeah,
more fractal on the Earth underneath you.
yeah. And some of the other implications I didn't write down here, some of the controversial stuff is, once I saw Haramain's work and how it's some of the information is on ancient pyramids, the flower of life and all that, and the ancient literature, then you start really looking at where does this come from and what's going on. It does point to either very advanced ancient civilizations or ETs, So that's one of the reasons why I find this stuff so exciting, is you get to get more people interested. And then when they dig into it and see where it comes from, it points directly towards advanced intelligence and civilization has been out there before us.
And we
So
call phase conjugation a hermetic science because the caduceus is phase conjugation in physics, perfect damping.
yeah, and that's the one area I got really inspired was the Hermetic tradition and studying some of Hermes stuff, and that it's really compatible with this stuff. So here's a quick summary. Vacuum energy density assumption that we started with at the beginning allows for calculating mass. We did that with black holes, the proton. And by the way, once you know the proton mass, that covers almost 100% of ordinary mass. So this is, in a sense, I think Haramain and what we've done, we understand mass now. We've developed some new equations using this approach. And when you study the fabric of the matrix, the fabric of space-time, and see how the vacuum, the toroidal, just the ether, how that might be, how one might move through the ether and the dynamics of that, it really does enable some visualizing of how things work in nature. Whereas before, with the mainstream science, like quantum mechanics, they just say, this is the way it is, it's what the equations say, believe it, but it doesn't give you a great insight. Well, this new physics actually can give you insight into how these dynamics work and a whole lot more. So it's
Like
simply
string
the,
theory is vortex theory, is wormhole theory, is
yeah,
phase conjugate, fine cones.
yeah. So that's exciting stuff. So this is for me and maybe a lot of people, it's the beginning of a whole new conceptual way of thinking of science. So I list the references here and wanted to point out that at Harriman's Institute, Hawaii Institute for Unified Physics.org, he has all of his publications here. This paper I've presented, the quantum gravity and the holographic mass. And then, of course, I use some of your stuff too, fractalfield.com and other things. So
Thank
we're
you.
done a little bit early this time.
Hmm.
We can
Well,
continue
maybe
talking though,
just
answer questions.
backing up one slide, Mark, where you, yes, the beginning of a new whole conceptual way of thinking of science. It would be good to think of if this gives us the clues to embed the role of mind in physics, because there's this whole the most difficult and challenging question of all philosophy and physics has always been the existence of mind. But if we now know that the plasma donut you make around your head when your brain waves phase conjugate and implode is actually a charge field we can measure you take with you after death. So when the focused human attention measurably causes electric fields to compress, Bill Tiller so well carefully measured, then we now beginning to understand mind and mass in a way that's not schizophrenic and not separate. If we know exactly the relationship of mass to charge, which is, say, charge when it's compressed and phase conjugate creates mass, then we can exactly know the role of mind. We make a centripetal force when our mind is focused, and that's been measured thanks to Bill Tiller, and that makes electric fields compress. Suddenly now we know exactly what mind is. It's the ability to create this phase conjugate foci that allows a centripetal force to be created. And we know that mind, the power of human focus, has the power to, for example, change the solar flares we measured 11 times. So you make a centripetal force and you make a contribution to the universe, a negentropic centripetal force from mind treating the nucleus as a phase conjugate pump wave. So suddenly we can embed the role of mind in our understanding of physics when we understand how plasma creates compression. And when you know how gravity is created, you know how mind is created.
Yeah, and Dan, that's so fascinating. That's as Elizabeth Rauscher has said on some of her videos and all, that the consciousness studies, that's the hard problem. The physics is the easy stuff, And I was wondering where's Harriman going to go with all his work? Well, if you've been following some of his latest papers, it is on consciousness. They call it space memory instead of space time now. You need
Yeah,
memory.
and the propagation of memory or information is basically where the plasma can be contained by centripetal negentropic phase conjugation. So, for example, Chris, who's helping us, implosionamp.com, the phase conjugate parametric amplification for over unity, is also now helping to coordinate the board for the Monroe Institute. And what we're taking the Monroe Institute is a new biofeedback mechanism to prove that psychokinesis and things like controlling flame at a distance is optimized by this biofeedback physics. You create phase conjugate frequency signature brainwaves, right left hemisphere, 180 degrees out of phase. Suddenly you know exactly how you make a flame in the mind. It's measurable and teachable in biofeedback. And so the role of mind among waves is teachable and can be optimized. So it eliminates this whole schizophrenia, because for how many centuries have people been saying, oh, mind and matter are separate? That's the point here. They're not. They're both a compression wave among charge.
Yeah, and haven't you mentioned that was it Ingo Swann? Who was the guy who could heat thermistor at a distance?
Exactly.
Ingo Swann?
That's the central hypothesis here is, for years we successfully measured, after Korotkov did, that the kids in Russia who could see without their eyes, the way he could tell when they were succeeding was their brain waves reached golden ratio alpha to beta. Golden ratio harmonic series in brain waves was peak perception in Korotkov's work and in the mind work, even though they didn't know it. And then I invented the Bliss tuner to prove that. We did it for decades. You could teach peak perception, Bliss, by teaching golden ratio conjugation brainwaves. What we didn't know is the right and left hemisphere had to be 180 degrees out of phase to phase conjugate. And so now we can teach it far more accurately. And we didn't know the exact frequency series was phase conjugate tuned to Planck, which is exactly the Schumann harmonics, which is how alpha beta brainwaves were originally invented. So suddenly you can have a whole biofeedback system to teach how mind converges, makes plasma centripetal. And that's not just like military psychokinesis, it's like lucid dreaming, remote viewing, and how you take memory through death.
Yeah. Yeah. And I tell you, I'd like to really go back to some of those fundamental equations before Heaviside took them out, to look at the longitudinal terms and all the other terms, and see how it relates to this. Because, I've studied antenna theory, transmitting, even saw some nice phased array radar stuff of the military years ago.
And we did that conjugate interferometry by making conjugate microwave, and you can do plasma containment, eliminating the need for all the atom smashers, because you don't need the magnets to contain the plasma. You do it with longitudinal microwave interferometry. All you need to know is how to make longitudinal microwave, and then how to converge it at a distance back into transverse, which is Tom Bearden, which is the Russian woodpecker, which is longitudinal interferometry. So that's the flame of the mind. And that is antenna theory, which is basically how the wave that goes down the antenna on the correct cone changes the transverse component to a longitudinal component. That's the compressional. And that's how you actually hold plasma in place at a distance, which is how a flame in the mind is born. And what Dingo Swan did was heating a thermistor at a distance with his mind, and he did it through a Faraday cage, proving it had to have been an electromagnetic longitudinal wave, sometimes incorrectly called scalar or torsional.
Yeah. Yeah, and one of the things I'm hoping that comes out of this is, like you said, devices that help us, we use in harmony with nature, so we can live independently and self-sufficiently, and then willingly, when we work together with others, to develop more stuff. But so that, the sooner we get devices out that show that this physics is real, the better.
Well, and the physics also says that, if this golden ratio of brainwave physics was how you achieve bliss, it means it's when your body becomes implosive and its own source of charge. So you become a zero-point energy source, just like a pine cone. And therefore, that is the definition of the end of being a parasite. And that's the zero-point energy is the same physics as human bliss.
Yeah, we have to be careful. We might, if we perfect it too much, we might go rainbow body. If you've heard of rainbow.
In the films of advanced Tibetans dying, rainbows occur. It's very definite, well known. You can't deny.
Yeah, I've seen the David Wilcock or someone talking about that, and that's some real serious.
And the physics is clear, because if you die correctly, your plasma force adds a centripetal force to your environment, negentropic and phase conjugate, and that is the reason rainbows exist. So in effect, you contribute to your world by making it more centripetal, the role of mind among waves. And that's why stars went to a lot of trouble to make people.
Yeah. I guess if you don't get it right, you keep on getting other tries to get it.
Actually, they say that our sun is a little tired now, so we got to stop doing Groundhog Day.
Oh, yeah. Okay. So, should we move on to questions, or just keep on? We can keep on talking.
Yes, questions are good at this point.
Yeah, I appreciate you helping out with this too, Dan.
Maybe I carried on too much, but we had a little fun. It's fun talking.
It's a great opportunity you've given me, and getting my presentation experience and all that. So.
Well, yeah. Plus, this makes our wave shareable, and these films go out. We have 1,000 people look at these films the first week every time.
Yeah.
We become a shareable wave, and the shareable wave is immortal by definition. The perfectly shareable wave is fractal and conjugate.
Yeah, and sharing the information, it's really important. That's part of the Sims delegate program is, I took his course, and you want to go out and share it with people. So that's one thing I'm working on doing, and contributing the best I can. So
yeah, it's great. And the electricity of that is actually the fact that grounding is essential for human health, the book Earthing. And what ground is electrically is access to perfected charge distribution called conjugate or fractal. Get fractal, get dead. So access to ground has the same electrical meaning for electricians as it does for psychologists, which is to say access to the reference point of perfected charge distribution.
Yeah.
Let's see. So in the comment column, Jennifer said no friction resistant superconductivity. Yeah, that's what we're saying, is that when the stellated tetra, which is called cube octa, jitterbugs to Ecosa, that's molecular physics and atomic physics of superconductivity, because the zero or conjugate geometry of the path to center of Ecosa dodeca eliminates resistance to spin, and therefore the reason superconductivity exists. And so when you have bliss in DNA, you get that superconductive effect, and you become more centripetal and more gravity making, etc. So that is the origin of no resistance, is perfect conjugation of fractality, which is the same as the origin of perfect compression, which is how you can eliminate heat during compression.
Yeah.
And Tobias is commenting here, orgasmic childbirth consciousness in living tree architecture. Yeah. Actually, in rebirthing theory, if you look at the geometry of pressure over time of the perfected birth canal, the physics of perfect rebirthing, you see a golden ratio point of max compression in the perfect birth canal, which means implosive phase conjugation, which is how we come to bring the memory of stars through birth, basically perfected compression. So it literally is orgasmic birth.
Yeah.
Which Nassim is into.
Yeah. So that one of the other things we talked about last week was the alternative energies, and just want to make a comment. You look at gas prices, how they're going down, and I've read that China and other countries are doing some research on say the Rossi machine and the cold fusion and other stuff. And I tell you, it'd really be interesting if that Rossi machine, the ECAT, was real, and it is based upon these new physics.
Well,
It would be it would be a world-changing thing. And sometimes I wonder if that's what's happening already, is people know it's coming, so maybe there's a lot of change. Speculation here.
Well, Rossi had isotope collapse, nickel to copper, and the isotope transition path had multiple paths because he wasn't sorting his isotopes before he began. So clearly, all the independent trials show excess heat, so obviously it's real. The thing is whether it's ever going to be controllable. Bill said he needed to sort the isotopes. So again, it came back to perfecting the path between isotope collapse. Non-destructive isotope collapse, the physics of alchemy, is cold fusion, which we now believe is conjugate. So you can write new equations for isotope collapse. We have a whole project on that called metamorphosis, focused out of Brazil. And basically, Joseph Champion calculated the temperature for a bunch of isotope transitions. But now, thanks to Bill Donovan and Elizabeth, we know the frequency and temperature for isotope transitions, physics of these collapse. So, and Roger, our sponsor for many of these projects, Roger Green, breakthroughtechnologies.com, fengshuiseminars.com. Roger Green is one of the lead investors for Rossi, and we've been deeply involved in that project. Roger flew Bill to the Rossi evaluation meetings in Miami and Bologna and Switzerland. And so we have a lot of background in that. It's clearly real. It's just the controllability requires a better understanding of the sequence of isotope transitions.
Yeah, and those isotopes, that's one of the things that the mainstream science says, well, for fusion, you have to have these isotopes or radioactive or different products, different things. And they are seeing these isotopes now. They measure the fuel before, do a spectral analysis before and after, and they're getting signatures of the different isotopes of nickel and helium-4 and stuff like that. So it is real. You're right about the controllability, but man, when I think about that, it would be so cool to have a energy supply that was clean, nearly limitless, and once we could control it, that would be really useful.
And it's no coincidence that Jean-Paul Biberian here, who leads the cold fusion projects of Europe from Marseille University Physics Department, and wrote the book introduced by the inventors of cold fusion. But Jean-Paul Biberian, half of his career was devoted to cold fusion and transmutation in biologic transmutations.
Yeah.
And biologic transmutations are related because it's the same fusion process.
Yeah, and this for me, I feel like I'm really lucky. I went the physics route first, and then found your work, and then I'm revisiting the cold fusion, because I'd looked at that years ago from a mainstream perspective and thought, well, I'll wait until they come out and say it's real. And then you wait a minute, they can't even explain it. That's why they ignore it. And it is real. They can't explain it with their science.
Well, it's
So
all about
the
non-destructive
need,
collapse.
yeah,
How
the
can an
need,
electron collapse into a proton unless the path
yeah,
is conjugate?
yeah. So I guess I'm just coming from like a mainstream. It's pointing out yet another reason why we need to revisit and redefine the foundations of science and physics so that we can explain really what's going on in nature. I mean, there's a lot of things that are unsolved. If you can't explain the galaxy rotation problem or the proton radius or cold fusion when it's actually, shown that these products are there, that means the theory needs to be reworked, and
When
yeah,
Dee and Kelly made the purest gold that the British Royal Society had ever made in alchemy in Prague, and they used a phase conjugate dielectric, ground up a philosopher's stone projected powder, and it was done in a magnetic pentagram, and actually it was an implosive path for phonon geometry. There's a sound component. So the path from mercury to gold is a very simple phase conjugate here. It's
yeah,
implosive collapse.
yeah.
So, and this
Well,
alchemy has to do with the human spirit, and there's a happily ever after there as we alchemize ourselves to implosion and we become projectable as plasma and take memory through death. So there's the happily ever after for today's class.
yeah.
So that's great. Mark, are there any other questions here from our wonderful audience? The way it emerges from the sun. Yeah, the way plasma emerges from the sun. Basically, the shaman experienced the heart of the sun as cool and inviting an eyeball for the same reason that the sun is doing fusion, and that means elimination of heat. I mean, physics basically does not know why Victor Schauberger's piezo water vortex spontaneously got colder just before it started making bullets from gravity. And the origin of that coldness is the negentropy called implosion, which Victor Schauberger made famous. And now we know that's the same reason why you call it cold fusion.
Yeah. Yeah, I always wondered about, like you said, the environment got a little colder beforehand. Well, there's that movie with the Fantastic Four with the Silver Surfer when he flies on a surfboard to Earth, freezing everything. I'm just imagining he's recharging his board or his energy or something, sucking all the energy out of the environment.
Well,
So
Ice 9 is nearly a name for the fact that heat is only a name for destructive wave interference. So obviously a phase conjugation is the solution to destructive wave interference, making it constructive. Therefore, it is the solution to heat. There might be some clues in global warming here in the sense that if you fix the dodecahedron of the Earth grid, what is eliminating heat?
yeah, yeah,
And we know the Schumann harmonics in the Earth grid are phase conjugate harmonic series to the frequencies of Planck. That's the equation on the cover of my book. So if you make Gaia more negentropic, you reduce heat.
yeah. Well, hey, Dan, I wanted to thank you too for this Fractal U University opportunity. It's like, again, it's really been good for me to execute some discipline and write a paper, do a presentation, and
Thank you.
on.
And Mark, let's look forward to publishing something together on this, connecting your equation to the phase conjugate model of gravity and rate commercial publication. And we want to point out to everyone in the audience that a serious collaboration of international electrical engineers gathers on conference calls regularly for implosionamp.com, fractalu.com, and hrv-app.com, and the whole fractal field, bioactivefield.com groups. So this is a collaboration that's unpacking here and growing. And so we want to thank Mark for that and point out that it's a continuous ongoing collaboration and more to come. So thank you very much.
Yeah, and you've introduced me to a lot of really active people in this area. It's really been a great experience.
Great.
So
And so
thank
we'll
you.
put this film at Mark's blog, and we'll also put it at the article we do with Mark, fractalfield.com/conjugate gravity. And so expect new results in our research soon with this wonderful collaboration.
Yeah.
Thank you.
Okay.
Mark.
Well, thank you. I guess that's it for now then. Well,
Blessings.
okay.
Blessings.
Thank you.
Thanks, everybody.
Okay. Bye.
Have a great night. It was wonderful, Mark. Thank you, sir.
Yeah. Thank you.
Okay.
Thanks
Bye,
everybody for attending. Bye now.
Get fun. Bye-bye.